Hey, so let's do another trig modeling problem. This time we're going to be given some values in a table and we have to try to come up with an equation, a trig equation that matches this. Let's take a look. Here it is, okay? So we're given from 1 p.m. to 1 p.m. the next day, okay? And here's the temperature. All right, so the x-axis is the time, the y is the temperature. Okay, and let's assume 0 is midnight, okay? So we're starting all the way at 1 p.m. Okay, and actually if you look at 1 o'clock here, so I guess we can start from kind of here, right? At 1, it's 16. And around 3, we're hitting a minimum. So minimum of 15. So let's say that's 15. And maximum of almost 30, 29, right? So 29 is there. This is the minimum. And we're starting from there, okay? So the graph goes from there and it'll go up and down, right? And then let's see here. Okay, so here, at 1 it's going to be 16. So I guess it looks something like that, right? Okay, clearly the period is 24 hours. Okay, period is 24 hours. So 360 degrees divided by k, right? K, if we do 360 divided by 24, it's going to be 15. Okay, so we need the k value and we need the middle value. So 15 plus 29, that's 30, 44. So this is 22 in the middle here. Okay, so we know it's going to be y is equal to the amplitude from 22 to 15 is 7. So it's going to be 7. And we're starting from, let's say, 13 here. If we start from here, then we can use the cosine function, right? So cosine 15 t minus 13, right? And then a vertical shift of 22. Okay. You could also, done a -7 sine function starting from the bottom as well. Okay, and then that would have been 15. This time it would have been t minus 3 instead, plus 22. Okay, either should work, but let's check. Is this valid, right? So for this one here, let's plug in, like, for example, 1, right? So y I'm in here to be the time. Time is a function, temperature is a function of time. So temperature at, let's say, 1, let's plug in 1 in there. Cosine of 15, 1 minus 13. Okay, try plugging it in. Okay, so when I plugged it in, I got 15 instead of 16. So again, it's not going to be perfect, but it got quite close, okay? Because this data here, the temperature in real life, doesn't perfectly follow. Like, the data will look something like that. It kind of is around the graph, but it's not perfectly on it. Okay, so that's what that means. So it's going to be, we can kind of understand the behavior is somewhat accurate, but we could be off by here the temperature is in degrees, right? So off by a degree or 2. Okay, maybe 1 degree. Okay, so now we're in a position to find 4 means just plug in 4. This means plug in 16. This means plug in 20.5. Okay. So I'm going to use this one, 7 cosine of 15, 4 minus 13 plus 22, and so on. Okay. So you should try plugging into the calculator and see if they will get the number and see if they make sense to you. Okay, so this is what I got. So around 4 o'clock, right here, right between 15 and 16, I got 17 reasonable. 16 is here, it's quite high. I got quite high value. 20.5, so let's look around 20. There, it's around there. Okay, so you can see it's a bit off, right? And perhaps we could have made it a little bit more accurate by, instead of choosing 29, we could have picked this to be a little bit smaller, like 28, right? But so your answer and my answer might be different if we were to do another problem like this together, right? You try it, I try it. You'd have picked slightly different numbers than I would have to make sure the model fits better the data. But the process is the same, okay? All right, that's it for this one. I'll see you in the next.